Hi, my name is Jennifer. Today I'm going to be walking you through My goal for this lab was to better understand the energy principle and how energy is transformed into different types. Using the rolling motion of the tape, I was able to examine rotational kinetic energy as well as translational kinetic energy. Before jumping too far in, we need to return to the energy principle in order to understand the experiment. The energy principle states that a change in energy of a system is equal to the work done by the surroundings plus heat. Using this principle, we can obtain that delta E equals W when there is no change in temperature. With the energy principle in mind, let's watch the video that I analyzed. Of course, a crucial part of the energy principle is defining the system and the surroundings. Here, we are defining the role of tape as the system, and everything else as the surroundings. We can then determine all of the different types of energy contributing to the system's total energy, including kinetic energy, both translational and rotational, as previously mentioned, as well as gravitational potential energy from the change in height over the ramp. To expand and work with our equation, we need to note that the mass of the tape is 81.88 grams, and it has a diameter of 7.3 centimeters, and thus a radius of 3.65 centimeters. Additionally, I derived the difference in height from my tracker analysis video to be 0.0579 meters in the negative y direction. Lastly, the final velocity was solved by the average velocity formula using data derived from tracker. I subtracted the position of the second to last frame from the very last frame, and then divided by the change in time between those two frames. Here is the work for the values discussed previously. Notably, I select the moment of inertia to be that for a hoop for the roll of tape, since its mass is present in a ring around an empty center. In an ideal system, namely one without friction, the change in gravitational potential energy should be entirely converted into kinetic energy as the sum of translational and rotational kinetic energy. However, we can see that there is a discrepancy between these values. Assuming the difference is not entirely due to my own errors, we can chalk the difference up to being a release of heat from friction of the tape with the surface it rolls on. Since we were not required to include code in this lab, I did not make a full model for this experiment. However, if I were to create a program to further explore this topic, I would want to model the experiment under ideal circumstances without friction or my own error. One interesting question to answer would be to compare the expected velocities at all points with the actual velocities. Doing so may allow us to see whether the friction was great on the ramp or on the table. As previously mentioned, this lab was not free from error. Most notably, there would have been a friction force in the direction opposite of motion due to the texture of the table, although it appears quite smooth to me. Additionally, the tape roll bounced a bit when it left the ramp, and that may have affected the position over time. In the spirit of our usual lab videos, I decided to ask myself what would happen if the tape were unrolling as it went along. Well, the loss of mass of the system would affect the mass-dependent energies, such as kinetic energy, and thus there would be a decrease in the total energy of the system over time, which would be lost to the surroundings due to the conservation of energy. Thank you for watching my presentation, and enjoy the rest of your day.